Okay, we're going to go ahead and get started as people kind of trickle in. I'm going to make a few announcements. Welcome everyone to our April Lunch and Learn. Thank you so much for joining the Georgia Arborist Association for this presentation. I have a couple of announcements before we get started. As always, please feel free to ask questions as we go through this presentation. If you don't mind, please put those questions in the Q&A and I will ask them as they arise. Also, there is one CEU credit that is associated with this webinar. I will put a link in the chat box at the very end of the presentation for a survey to fill out. If you'd like CEU credit, then you can just fill out that survey. Let's see, a couple of announcements about our upcoming programming. Next month's webinar is not actually going to be a webinar. We're going to move back to an in-person training. So next month's training will be in the evening, and it was going to be at the Vermeer Southeast location in Marietta. So I hope you all will join us for that. The topic for that presentation is going to be Trees and Law 3.0. That's going to be with Lee Clark from the Georgia Forestry Commission and Kay Ivanovich. The topic for 3.0 is, I believe, the title of the presentation is So You Want to Be an Expert Witness. So please feel free to join us. The registration is already up on our website, so I hope you'll join us for that in person. We'll also be giving membership updates, and it's free as always if you're a member of the Georgia Arborist Association. Also, our presentation today is with Chris Hughes of Brookwood Tree Consulting, and he's actually the instructor for the tree and plant appraisal qualification course that we will be hosting. So if you're interested in that, that will be in July. So also check our events page for the registration for that. That is a American Society of Consulting Arborist course that's very fascinating. So I encourage you to look into that, coming to that in July. So those are the announcements that I have for you today. I hope that you'll join us for some of the upcoming programming. And so without further ado, I'd like to welcome our presentation for today with Chris Hughes of Brookwood Tree Consulting. Welcome, Chris.
Thank you, Jesse. I'm happy to be here. Happy to be presenting to all these knowledgeable folks. Hopefully I won't make a fool out of myself today. As Jesse said, I'm Chris Hughes with Brookwood Tree Consulting. I have had this business since 2010. I worked for about 10 years in the nursery field. Prior to that, I've put my hands on quite a few trees over the years. And one of the things that we're going to talk about today is design professionals and arborists, the benefits of collaboration with arborists, and some of the principles of arboriculture. This is a presentation that I put together and gave last year at the UGA College of Environment and Design Landscape Architecture short course, which is a mouthful. But, you know, in my experience, I've seen the benefits of collaboration. I've experienced some of the downsides to a lack of collaboration. And this was really designed to kind of help, convey the message of how we as arborists can benefit design professionals, landscape architects, civil engineers, architects, and even developers in their projects to create a better end result. So without further ado, let's dive in on the topic. So we'll hit kind of three things today. Again, arborist, arboriculture, and the benefits of collaboration is the topic. As my mother would be the first to tell you, I always like to say why. Why as a child was probably my favorite question. So why trees? Well, the human experience is better with healthy trees. We have plenty of research that kind of backs that up and supports that concept. I don't think that's a controversial topic. Trees provide environmental benefits. Once again, we have significant evidence that this is true, not controversial. And trees provide economic benefits. Hopefully everybody's with me so far. It is unusual. I will tell you, I'm more used to giving presentations to roomfuls of people where I can see eyeballs on me. Talking to my screen today is a little bit different. Then we'll dive into what are the benefits and why, or what are arborists? Arborists are the experts in trees and the human environment. That's what separates us from foresters. Foresters are dealing with trees as a commodity. Arborists are dealing with trees as a human benefit. We have specialized training in the assessment and care of trees. And then how can an arborist benefit a project through some collaboration? Well, we can conduct tree surveys. That's fairly obvious. But not only can we tell you what's there, we can tell you what kind of condition it's in. Is this tree worth conserving? If it is, we can also provide preservation plans, prescriptive plans, plant health care plans that will help that tree be protected through the development process and help see that it thrives beyond the development process. We can also assist in tree selection, getting the right tree in the right place, and sustainable site development, kind of carrying that site forward beyond the construction phase to where it really has to live and breathe in its operational phase. Do that in a way that helps the site be more sustainable, so that we're talking about management and not maintenance of trees, and they're allowed to kind of grow and develop into what we all want trees to be. As I said, my name is Chris Hughes. I'm the principal arborist at Brookwood Tree Consulting. It's a small consulting firm. There's currently 2 of us. I am a registered consulting arborist through the American Society of Consulting Arborists. I'm also currently on our board of directors for ASCA. If you've not joined ASCA, I suggest you look into it. It's a really unique space of about 800 members who all have extensive experience and knowledge in trees, and particularly consulting. I'm an ISA certified arborist. Brookwood Tree manages tree care programs from 1 tree to campuses of over 3,000 trees. I use this number of how many evaluations. I actually think it's probably a little bit low. But we'll say we've been in business for 15 years, and I probably look at 10,000 trees a year. So that feels like a pretty good number. 150,000 trees that we've looked at. Also deal with expert witness and legal consultation, primarily revolving around tree appraisal and teaching the tree and plant appraisal qualification course that Jesse mentioned. That's coming up in July. I would love to see some of y'all there. We had a great group in August of last year, so would love to see others join that as well. If you've got any questions about that, please feel free to reach out to me. I think at the end of this, my contact information will be there. You can also find me at brookwoodtree.com online. If you have any questions about the topics we talk about today, and don't ask those here, if they come up later, please feel free to reach out. If you're interested in pivoting to a career in consulting arboriculture, you want to be a consulting arborist, please reach out. I'd be happy to help you talk about what the career is like. Also talk about, what opportunities there may be to get into it. So getting into this presentation, arborists have the best offices. Let's face it, we all went into this work primarily because we wanted to be outside and not behind a desk. We wanted to be out among trees, not just looking at pictures of them, but trees really give us the best offices. And as I've said before, we work at the interface of people and trees. Foresters deal with trees as a commodity, as a product. We're dealing with that overlap and that interface of where trees and people have to coexist. In an urban environment, this is downtown Atlanta, the real estate's finite. We're not going to be able to make any more land, and the competition and the demand for that space is high. So we have to figure out ways to coexist. How do we get trees to function in a way that they augment the urban environment and make it a much better place where people want to be? And if you go into those places, even without direction, people will find those environments. There's a distinct connection between people and trees that makes these spaces special. And that's where we get to live. We get the best offices. Like I said, sometimes we have to bushwhack for 30 minutes through blackberry to get to a tree. in the hot August sun, but it is worth it. Because trees are beautiful in a way that moves us. We are all very familiar with the ginkgos. When they change in the fall and shed their leaves in 24 or 48 hours, this is in Decatur at Agnes Scott College. 2 beautiful ginkgos on campus there as they shed their leaves. And trees are very forgiving. They are the ultimate embodiment of resiliency, in my opinion. This is the tree of heaven, which most people would quickly denigrate as an invasive species, but we have to respect the capacity for that tree to grow in the seam between the concrete wall and the asphalt. Trees are also beautiful in a way that growth returns each spring. If you can tell, my voice is a little bit gravelly today. I'm affected, like many of you probably are, by our current pollen count. So all these trees are leafing out. But one of my favorite things about leaf out, when buds break, all the cells that make up the leaves and the stems and the flowers and all the new growth, all the differentiation has already occurred and everything's packed up inside that little bud. And when water returns, complexity is built on simplicity. Those cells exist and they start to fill up with water. The bud opens, the stem elongates, the leaves expand, and here you see a hickory bud opening. You come back in another month, there's that same hickory bud. All the cells that make up the leaves and stems and new growth that we see in this photo existed in this photo. It just blew my mind when I first learned that, and I thought, I've got to get further into this world. Roots are the reason for that. Like I said, it's the movement of water from the soil up through the tree and out to the bud. And root hairs are really the source of that. And if you're not familiar with root hairs, they are a modification of a cell within the roots. They're ephemeral. A root hair in the cell that it belongs to usually only lives for about 2 weeks. That's what my buddy Mark Hartley taught me in the tree anatomy course. Root hairs live for about 2 weeks, and they're responsible for the bulk of the water absorption within a tree. And they're really just an elongation, a modification of a cell. And this is a representation, kind of a digital microscope representation of root hairs forming and elongating. But you can find them under a microscope. This is root hairs. In the center of that image, you can see clusters of root hairs bound to some of the soil particles there. That is where your water absorption is going on for the tree, even within the root, and even within what we oftentimes term feeder roots. It's even that finer of a slice beyond that small white root, just the root hairs. So the entire tree is supported by these cells. We move up in the tree from root hairs to probably the strongest visualization you could create of a representation of a tree. The flare at the base of it, the buttress at the base of it, all these roots developed from that same fundamental structure that we saw a couple of slides ago. This delicate, fine, ephemeral structure ultimately develops into this broad, solid base of the tree. And the entire tree is supported by these cells, both in the concept of water movement and nutrient movement, oxygen movement, but also quite literally. This is supporting the tree in its wood structure, keeping the tree upright. And this is obviously a diagram that many of you have probably seen before, but it's just helpful to get some terminology out. And so we're all using the same terms. The upper part of the tree we call the canopy of the crown. The drip line is the furthest kind of general extent of that above the soil. Below the soil, we see the root zone. We know that oftentimes that root zone extends well beyond the canopy or the drip line at the edge of the canopy. And this whole tree grows based on 5 fundamental necessities for tree growth. Usually in a classroom, this is the point where I would ask everybody, what are the 5 fundamentals of tree growth? But since you can't speak, I'll tell you. Water. Obviously, the roots we just saw are taking up the water from the soil. Sunlight. It's coming out of the atmosphere. So not only am I telling you, I put these down on this slide where those things occur. We have oxygen. Roots are responsible for taking up oxygen out of the soil along with water. Carbon dioxide, along with sunlight, coming out of the atmosphere. And then minerals, all the, nitrogen, potassium, phosphorus, micronutrients, macronutrients, the things that we think about as chemical compounds or ions in the soil that the tree needs are taken out of the root system. And when we talk about the fundamentals, sunlight and carbon dioxide, generally speaking, are not going to be limited. There's an abundance of both of those to support minimum plant life. Where we're dealing with challenges is at the root system. Water, oxygen, and nutrients are generally going to be the limiting factors for supporting healthy plant growth. So perspective, again, with design professionals, arborists bring a different way of seeing the same thing. We generally can all agree that trees provide value. They help scale our cities. They provide aesthetic. Those are kind of the tangible values. There's also intangible values like environmental, social, and economic benefits. So why do we need trees? What are those intangible values? Trees are an integral part of our urban spaces. Social benefits, a few of those. We get better mental health. Research has shown better physical health. Trees help us reduce stress, feelings of stress within people. Studies have shown there's higher academic performance related to trees around academic buildings and in schools and campuses. Research has shown faster recovery from medical procedures when there's trees and views of trees around hospital and medical facilities. So a wide range of social benefits. Environmental benefits, everybody's probably pretty familiar with. Trees reduce ambient temperatures by providing shade. They improve air quality by intercepting particulates in the air. They improve water quality by slowing down precipitation in the water cycle. Natural stormwater control. We'll have a great video here in a minute, but I love to show people about that. And then economic benefits, again, through shade, they're reducing energy consumption, also through evaporative cooling, increased property values, coming back to that aesthetic of trees. There's also research that shows that trees help retail prices be higher, help leasing rates be higher, help retail prices and leasing prices be higher. Much of that research was done by Kathleen Wolfe out of Washington, but it was conducted in our very own Athens, Georgia, downtown spaces there. So trees provide a lot of benefits. 30% lower incidence of depression. So we talk about improving mental health. German Center for Integrative Biodiversity Research concluded that 30% reduction in depression amongst adults based on trees and being out among trees. Landscape and Urban Planning from the University of Illinois found that there was an increase in attention scores for students by 20%. That concept is known as the attention restoration theory, if you'd like to look at that further, but it's really fascinating. Simply having views of trees and being out among trees lowers stress levels and reduces anxiety in students. And lo and behold, with reduced anxiety, students do better in school. And 6 minutes is generally the amount of time that they found people needed to be immersed in forest to see an improvement. So not a significant commitment, really, to see improvement. 6 minutes of walking in the woods will give you some benefit there. And if you don't believe me, you can read a book about it. And if you don't like that book, you can read another book about it. If you don't like that one, there's another book. And if you don't like that one, there's more, and there's more. And the one thread that connects most of this together is that the benefits are all tied to spending time outdoors. And when we have access to nice spaces and calming spaces and well-maintained spaces, access to nice woodland areas, people benefit. People came from trees, people will return to trees. Environmentally, we see a 6 to 8 degree reduction in ambient temperature based on tree canopy. We see a 35-degree reduction in solid surface temperatures. So the sidewalk in the sun versus the sidewalk in the shade, there would be a 35-degree reduction in the temperature on those surfaces, or a slide on a playground. We get 10% increase in HVAC efficiency, and that's more related to shading of the actual equipment itself versus shading of the space that's trying to be cooled. The image over on the right, if you're not quick with your geography, that is the city of New Orleans. The Mississippi River is the serpentine gray band on the bottom of the image, and Lake Pontchartrain's at the north end or the upper part of that image. Those colors, I've already clipped the change, but I believe that's where we're seeing that 10-degree temperature in ambient air. In the core urban area of New Orleans, it's about 10 degrees warmer than it is out in those cooler blue areas. And this was a NASA research image and study. And the major link between those was the prevalence of tree canopy. This is the video I mentioned a minute ago about trees as natural stormwater control. If you think about the visual image of a tree, just everybody visualize one in your mind right now. It mirrors a funnel in many ways. And so when it rains, the leaves, the branches, all those above ground parts of the tree intercept that rainfall, and you'll get the sheet flow of water across the branches, onto the trunk, down to the base of the tree where the roots are located. And I know we showed that diagram of the roots spreading far and wide, but even in a forested setting where it's not quite as comprehensive, the tree is still intercepting rainfall and depositing at its base. 50 gallons of water is what a mature tree intercepts during a large storm. And a large storm by this study was defined as 1/2 inch of rainfall per hour. In Georgia in the summer, I would say that's probably a fairly moderate thunderstorm. You know, we can easily get and frequently get storms that are twice that, a bunch, above 1 inch per hour or more. So significant rainfalls are common, and a tree can intercept quite a bit of that. University of California at San Diego, estimated that trees on their campus capture 140 million gallons of stormwater each year. I was a bit blown away by this. I didn't know that San Diego got 140 million gallons of water at all, but apparently it gets more than that, and the trees are able to sequester that. That 140 million gallons translated to about $250,000 per year that their trees on campus were saving them. And I believe that was a figure that was drawn based on the equivalent stormwater systems that they would have to put in place to treat that. So again, we come back to this arborist, arboriculture, and the benefits of collaboration. Why? Human experience is better. Trees provide benefits. What? Arborists are the expert in trees. And then how? We can do this through surveys, assessments, preservation plans and prescriptions, tree selection, and sustainable site development. So let's talk about what an arborist is. Most of you probably are familiar with that definition. But the three most common types of arborists, we have the ISA certified arborist through the International Society of Arboriculture. That certification means you've demonstrated a basic understanding of trees and arboriculture. You have at least 3 years of hands-on experience, and you've passed a 200-question multiple choice test. That's the basic certification within our industry. As a result, there are about 30,000 certified arborists worldwide, and the International Society of Arboriculture certifies arborists around the world. There's also the ISA board certified master arborist, and there's a host of other certifications and qualifications, but I'm just hitting on the three most common types of arborists. So if you are a certified utility professional, don't get mad at me. We're not really talking about that today. So BCMA is what this is abbreviated as. That is the highest credential or certification that the ISA offers. There's a greater experience requirement, and you have to pass an exam that has scenario-based multiple choice. So based on the scenario, the answers can change. And then finally, there's about 1,500 BCMAs worldwide. And then finally, there is the ASCA Registered Consulting Arborist, or RCA, as that's shortened to. That credential is focused on consulting. There's an experience and education requirement. You attend the ASCA Consulting Academy, graduate the academy, and submit a series of reviewed reports, and you can achieve status as an RCA. So there's the academy, there's an exam to graduate the academy, and then there's those scenario reports. And there are about 350 RCAs worldwide. So depending on what you do or what a consultant does or an arborist does, each of these kind of makes a little bit more sense based on what their specific work that they do. An arborist versus consulting arborist. Consulting arborists are experts on trees and bring an objective, comprehensive viewpoint to ensure the safety, health, and preservation of trees. A consulting arborist can be a certified arborist, can be a board-certified master arborist, or can be a registered consulting arborist. It's not like being a lawyer or a doctor. Anybody can call themselves a consulting arborist. But those credentials, if you want to use those, you have to work through those organizations that provide those to be able to call yourself a registered consulting arborist or board certified master arborist. And I just see that I have a typo there. It's BCMA, not BMCA. So points to consider when working with an arborist as a design professional: seek experience and expertise relevant to your project. That kind of feels like a no-brainer. If we're doing construction and we want to work around trees, working with somebody who has experience in developing tree preservation plans for construction would make sense. An ISA certified arborist has demonstrated the basic knowledge to inspect trees and perform tree care. An ASCA RCA has demonstrated higher skills in certain technical areas related to trees and tree care, providing objective, independent opinions and training for higher communication, presentation, and report writing skills. That is much of what the Consulting Academy is about, is how to conduct yourself as a consultant and how to communicate that information to your clients in a way that is concise, clear, and relevant. As a professional, I can tell you, going to the Consulting Academy was the biggest benefit to my development on this career track. It really taught me more about not only my knowledge, but how to convey that knowledge to others in a way that made sense. So, again, as an ASCA board member, I'm going to give you a shameless plug, but as Chris, I'm going to tell you, truthfully that it was really a career-changing experience. So what areas can a consulting arborist assist in development project? Obviously, we talked about surveys, tree surveys and assessments, locating and assist in preserving trees, tree selection and establishment. We can assist with species selections and installation for site conditions and design goals. Consulting arborists can help with tree preservation, plans and prescriptions to conserve existing trees and tree canopy. And then sustainable site development, long-term health and longevity of trees. Today, we will talk primarily about those top two: tree surveys and assessments and tree preservation. Maybe we can come back and do the other two at a later time. So tree surveys, consulting arborists provide tree surveys. We work a little bit differently than the land surveyor. Typically, these are going to be GIS based. Utilize a GPS unit, accuracy counts. Within my practice, we use the Bad Elf Flex unit. We can get about 1 foot of accuracy underneath tree cover on a consistent basis. Sometimes we can get even better. with RTK, which are real-time corrections on that, where we can push it down to 6 inches or more. But for most tree survey purposes in most municipalities, within a foot is usually good enough for trees. Anytime that it's very close, though, where we're really being tight in our preservation goals and every foot counts, we recommend a surveyor get you very precise tree locations. An arborist is generally going to give better measurements of tree size. So typically within a tree survey for a project, that's going to be DBH, or diameter at breast height. I've seen numerous surveyors get this incorrect. Some of it's based on their methodology, some of it's based on their use. That's not specific, or use of equipment. It's not a specific degradation of land surveyors, but it is, we're the trained folks. We know how to measure trees. We know how to account for abnormalities or eccentricities or atypical trunk forms. Any of those things, we know how to work with that and get an accurate measurement of the tree. We also get accurate species identification. Most arborists are going to be very good at identifying trees, telling the difference between a white oak and a water oak, or a pecan and a tree of heaven. And then we can also at the same time assess overall tree condition. Is it in good condition, or are there significant structural challenges or health challenges related to the tree? We'll talk about a few more of those here in a minute. And tree surveys aid in the compliance with tree ordinances, but also can help identify trees worth preserving through construction. We obviously do a lot of work in the metro area, helping people become compliant with trees, but I was in late last month or earlier this month, we were out near Augusta working on a project that's being planned out there. No tree ordinance, all the design goals. And so we're helping inform those decisions as a project is laid out, as a site gets planned. What are the trees that are here, and are they really worth working around? And if yes, how are we going to do that? Typical deliverables include a survey map, tree tables, photos documenting condition, and digital files of location and data. Our native software is going to be shape files, or utilize shape files. Those are a little bit different than CAD files that most design professionals are going to be used. And those two softwares fundamentally run off of different things. Shape files and GIS software runs off of points, and CAD software runs off of lines, and points and lines are very different. So make sure you understand how you can move that information between those two systems in a way that's going to be reliable and useful for your client. So arborists improve the end result with tree surveys by assessing the overall tree condition. Obviously, that's broken down into 3 areas: health, structure, and form. These general assessments provide broad characteristics and is sufficient as a first pass evaluation. It may lead to a more in-depth evaluation of the tree, but this is kind of the first step. And the criteria can be independent of or related to other components, meaning we can have a tree with perfect structure and ideal form, but it's dead. The health is not good. And so those 3 components can be related, or they can be totally independent of one another. They don't rely on each other. So basic assessment will evaluate health. What is a tree's health? Well, that's the vigor exhibited by the crown, density, crown cover, and leaf color. Essentially, is the tree alive? Is it growing and functioning from a physiological standpoint? And that's oftentimes tied to the tree's ability to withstand predation by pests and resistance to adverse conditions. Trees and plants adapt by growth. People and animals adapt by movement. Trees can't move, pick up, and change their location. If conditions change, environmental conditions change, they have to grow to a new favorable balance. Also assessing any degree of dieback. There's a picture on the right. We'd probably call that 100% dieback in that tree, but it may not be quite there. And it's important related to the viability and longevity of the tree. Again, how much can this tree be impacted from a development standpoint and still be able to withstand that and come out on the backside of the construction project with some longevity still intact? So health, some things to look for. Again, dieback, this isn't a great photo, but that's a white oak and a lawn, and there's extensive branch tip dieback throughout the canopy. If you're not familiar with this process, that upper canopy is the furthest from the root system. And remember, the roots are where we're getting water, oxygen, and nutrients. And so a tree of this size requires a fully functioning system to be able to move water passively. It's not an active process. There's no pump pushing that water up 80 feet in the air. It's all a passive process based on surface tension of water and some other inherent components within the tree. But again, you're getting a passive process, so it requires a fully functioning operational system to do that. Even though it's passive, it's still a system. We're also looking at fungal or bacterial disease, bacterial leaf scorch in this photo of a red maple on the right. Insect predation, we have pine bark beetle in this photo, but there's a host of borers and bark beetles that are common to trees and especially stress trees. And we can evaluate foliage size and color. In this image here, we have two willow oaks as street trees. The one on the right is full of dark green foliage. The leaves have expanded, what we would expect out of a willow oak leaf. The tree on the left, you can see a thinner canopy, slightly chlorotic, and the leaves are smaller than what you would expect. So we can easily identify that there's something else going on with that tree on the left that's preventing it from growing like the tree on the right. And then we can look at new growth and stem elongation. Again, all those cells, like we talked about, all those cells that make up the stem and the leaves exist in that bud. And when they open, it's the application of water to those cells, filling with water that causes the expansion and elongation of the stem. This is the Nuttall oak. In the lower left corner, you can see where those two stems of new growth come back together. That would have been the original point, the point of new growth. This spring, we have about what appears to be about 12 inches of new growth. And then you can even see in the upper center there's a second flush of growth coming out. So oaks, healthy oaks, you may get 2 and 3 flushes of growth per year out of that tree. So we're seeing a second flush of growth here, indications that this tree is healthy. But it may not be structurally sound because basic assessment will also look at structure. This is a tulip poplar, very healthy in that one branch that it had, but every other part of the canopy had failed and fallen away. And we had major structural issues, obviously, in the center of the tree. This is just as an example of an extreme condition of structural integrity there. So that's the ability of the tree to keep itself upright, the load-bearing part of the tree to sustain its resistance to loading forces under normal conditions. And that's a $100 word soup that basically just says the tree's ability to keep itself upright. It includes the trunk, major scaffold branches, and smaller branches and roots. Visual signs of structural problems may include cavities or voids, cracks, seams where there was a crack, but the tree has at least externally compartmentalized that, decaying wood, and or fungal fruiting bodies, everybody's favorite. And we can also use acoustic sounding. Again, in this initial assessment, acoustic sounding of the trunk can reveal internal problems that we may want to explore with a more thorough assessment later. But acoustic sounding with a sounding mallet or a hammer. My experience has told me there's not a significant difference between sounding mallet and hammer type. The consistency of what you use and understanding your tool is usually more important than the tool itself. So being proficient with that tool is the most important part. And that applies to a lot of arboriculture at large. Be consistent. That will increase your reliability and your credibility as an arborist. So things to look for in structure, obviously cavities or voids, decaying wood. This is an open crack in a red oak, but we may have a seam where that has occluded on both sides or compartmentalized externally. And then fungal fruiting bodies, everybody's favorite in a notice. And then finally, a tree assessment would include form, basic assessment of form, and that is the shape of the crown of the tree, or the silhouette that the tree cuts is kind of what I've always thought of it as you thought of the silhouette that tree would provide. Form is influenced by the availability of space and light. You'll oftentimes see deep in the woods where trees are spaced together tightly, they're not mingling in canopies. Each tree is fairly distinct in its own space, and that controls the growth. Can be dominant, codominant, flourished, intermediate, or suppressed. Those are different canopy form criteria that we utilize. And it's important related to the long-term viability and structural integrity of the tree. So look at this image on the right. We can say initially that there are some form asymmetries with that tree. It was likely codominant. Actually, I know for a fact that it was codominant. On this neighboring property to the right, there was a tree there that has been removed. This red oak was growing over the property line, searching for open canopy. But if you look in the very center, lower center of the canopy of the tree, since the other was removed, we're getting new growth, two dominant vertical sprouts of new growth with secure attachments. That tree is adapting to its new condition. It's responding with positive growth. And so where the form may have been codominant, this tree may be on the path to returning to a more dominant form and therefore presenting itself in a better, more stable situation in time. And we can develop potentially some management strategies of how we would deal with that tree, over the next 5 or 10 years in a way that could restore it again to a dominant canopy form that's going to be long-term sustainable. I talked about those different crown classes. These are the ones that we oftentimes use in our assessments. We have codominant trees, which are best preserved in groupings. We have subordinate trees. They're a poor choice for preserving due to their inferior structure and sudden exposure. That's this little guy on the left that's marked with an SU. That would be a suppressed form. If that was an oak, even if we took away the two codominant trees above it, that tree's never going to be able to develop, or it's unlikely that that tree is going to be able to develop into a dominant form. The codominant ones above it could stay, and the suppressed form could stay underneath that, but isolating this suppressed form is going to be more likely to be a problem. And the same goes for the two codominant trees beside it. Together, they make a good form or a solid unit, but individually, they're going to be more susceptible to problems. As you move to the right, we have this tree labeled I, intermediate. It's growing between those. If this tree were growing higher and then we had a larger canopy in the open space above it, we could call that a forest form, where it's a very long trunk, isolated. The live crown ratio of that tree would not be good, but in its forest form, where it's buffered from many winds, it's probably okay. And then in the center, we have our dominant crown class form. This tree makes the best option for preservation because it has developed its own with self-sustaining structure in the canopy. And I know I use structure there informally. We'll call that little f structure, but the structure at large makes the canopy structure makes a robust form that is the best option for preservation in this situation. There's common tools utilized in a basic tree assessment. We have a diameter tape. We can wrap this tape around the trunk at a standard height of 54 inches. It's going to be calibrated on one side to convert circumference to diameter for us, so we can quickly do that without any extra math. The manufacturers already did the math for us. We can have a hammer or a mallet for acoustic sounding. Binoculars for doing a visual assessment of the canopy, looking at stem elongation, leaf size, leaf color, if it's in season. We can look at the stem elongation of past years as well. As you kind of work down the stem, you should be able to see the internodal distance between those and at least classify that as typical or not. We can use the binoculars to look at the scaffold branches for any abnormalities there, anything that may indicate cavities or voids or decay or cracks. We can have a soil probe, both for taking soil samples, but also probing cavities, checking depth and soundness of wood within the tree. These tools will help you gather basic information related to the tree and its condition. Once again, this is really kind of step one in the process. This is one of my favorite sayings of all time. A fool with a tool is still a fool. Have to know what you have and how to use it. And I don't know exactly who said this, but I'm sure it was someone famous. Advanced tree assessment. So as we get further in this process, we can look at the trees in a little more granular level, provide more detailed information related to a specific tree part, a specific defect, or condition. So we determine that there may be some decay in the trunk. What's the extent of that decay? How can we tell whether this tree is still sound or not? And more information can assist in determining if the tree or part of the tree can be conserved or should be removed. Utilize specialized equipment to look more closely, and it focuses on specific trees or problems and are typically not practical for all trees on a site. If we're surveying 500 trees, we probably don't need to do this at the first pass. This is really those critical trees or the trees that come back with some questions that we want to understand a little more fully. These things are going to oftentimes look much more like a level 3 inspection, but it may or may not be a risk assessment. That may not be part of your assignment. It may just be the assessment itself. So common techniques and tools for these advanced tree assessments include a tree tissue starch kit. So we can take a root sample or a stem sample and test the amount of stored energy that the tree has inside of it. This is really useful, again, if we're looking at conserving a tree from a code standpoint. Tree ordinance may say, well, 20% impact is our threshold. If it's under 20% impact, you're good to go. If you're between 20 to 30% impact on the critical root zone, then you need a tree prescription. And over 30% impact to the critical root zone, you got to remove the tree. The tree's destroyed. And that's a good rule of thumb, but like most rules of thumb, it doesn't really get down to things at a granular level. As a case in point, we may have 2 white oaks on a site. We may be impacting one white oak in its critical root zone by 15%, but we test the roots and find that that tree has a low storage of starch in its roots, so it does not have a lot of stored energy. It's going to be less resilient to any impact. So even though we're below the threshold from a code standpoint, we might want to develop a broader prescription to conserve that tree, or we might want to advise the project team that we need to reduce the impact of this tree. We need to do less impact of this tree if we want to keep it healthy and survive through construction. Conversely, we may look at a tree and test its starch and have a very high starch content in the roots. That may inform us that we can go beyond the 30%. And even if we're going to quote unquote destroy the tree, and we may pay the recompense for that, we feel like we can be strategic in that in a way that this tree is going to be able to survive that impact, and not only survive, but continue to have longevity and viability past construction. It's a very useful and cheap way to test trees. We can use sonic tomography to scan the trunk. We can use this to tell, with a minimally invasive process, what is going on inside the tree. So if a sounding mallet indicates there's some decay, or we see some fungal fruiting bodies on the exterior of a tree trunk, we can use a sonic tomography to minimally invasively test the internals of the tree and get a reading and a visual reading at that of what the wood is like inside the trunk. It tells us how altered that wood is and how well that tree's compartmentalizing. So if we are all good stewards of the compartmentalization of damage in trees, we need to try to have some assessment of how the tree's compartmentalizing without disturbing that. We generally don't, in my practice, recommend or utilize a resistograph, because to get a detailed description, just feel like that's doing potentially too much damage to compartmentalization zones and may further exacerbate the problem. But your results and mileage may vary, so resistograph or a drill can be a tool to help determine the soundness of the wood. And then an air spade is another great tool. We can see where roots are going, where they're not going, and evaluate what the potential impacts would be. We can also use air spades in the construction process, but we're not quite there yet. This is still in that assessment phase. And then an aerial canopy inspection, we can bring somebody in to climb the tree, investigate a cavity a little further, investigate any cracks that we may see visually, and look to get a better determination of the extent of those problems. So tree preservation, common techniques and tools for advanced tree assessments include critical root zone, establishment and protection. We all know the beautiful orange fence that never seems to keep itself upright, but it at least delineates the construction and critical root zone interface. We have root pruning beyond that. There's some recent research that suggests that root pruning, I know standards in mind included, always pushed for clean cross-sectional cuts that minimized your surface area of your wound. There's some research out of Australia that suggests that a broken branch or a broken root with a rough edge actually responds better than a clean cut. Nutritional treatments, so whether those are soil injections or maybe a different treatment, we can provide nutrition to the tree. Pruning programs to clear building faces or clearance for vehicular clearance, or even construction equipment clearance. That's a significant one that we always face. And then supplemental watering, the most critical component to life. We oftentimes forget in our tree preservation plans. And on a construction site, water can be hard to come by. So thinking about that ahead of time, who is providing the water and who's responsible for putting it out on the tree at what frequency? Photosynthesis cannot occur without the presence of water. So we fundamentally have to address that in trees to be successful. So why collaborate with an arborist? Bring us in to the end now. Benefits of collaboration, key point, expertise and knowledge. You design professional, you can plan outdoor and design outdoor spaces, you consider functionality, aesthetics, and sustainability. Arborist, we have a much narrower, but I think very deep understanding of trees, specialize in tree care and management. We have expertise in tree health, maintenance, and preservation. What is the result of that? Benefits of those collaboration? We get a comprehensive understanding of site constraints and opportunities. What's going to limit this, and where can we really dig in or lean in? What are the opportunities that we have? And we ensure the integration of trees into the landscape design. We're talking about trees on a project 2 years in advance. We can help facilitate the design and meet the requirements of the project while preserving trees if we just start these conversations earlier in the process. Key point number 2, design and planning. Design professionals create site layouts, hardscape design, planting plans. They consider the spatial organization and visual impact. How are people and vehicles and other uses going to move through the space? How's the space going to be accessed and utilized? We get a broad range of considerations. Consulting arborist, we're going to have a narrower but deeper assessment of existing trees and their condition, recommendations for tree selection, placement, and preservation. Narrow band, but with more depth. So the benefits of the collaboration: optimize tree selection for site conditions and design goals, integrate trees to enhance aesthetics and functionality. And then key point number 3, sustainability and long-term management. Design professionals incorporate environmentally friendly design principles, implement strategies for water conservation and stormwater management. Well, here comes our consulting arborist. We can develop tree care plans and maintenance schedules, monitor tree health, and provide management recommendations. And so the end result, the benefit, we enhance the ecological value of the landscape. We ensure proper tree care, long-term health, and vitality. So a case study, we'll wrap this up. This is one that we worked on a few years ago with the University of Georgia Office of Architects. Hughes Environmental Design was landscape architect, and McCarthy Building Companies was the general contractor on it. And I went out and walked the site with Josh Coons, UGA Poultry Science Building. There's a significant amount of investment and research in poultry science. If anybody's heard of the bird flu, you might know why. So this is an existing parking lot. If you're familiar with the UGA campus, there was a parking lot here and kind of a green space next to the graduate library. We're doing a site assessment, looking at what trees are out there. It's your general mix of kind of mid-20th century landscape plants. We had water oaks, tulip poplars, Yopon holly. There's your classic water oak, over mature with decay in the trunk, mistletoe in the canopy, significant number of problems. But what is this guy that we see behind it? A Formosan gum. And I actually was familiar with this tree because I learned it when I was at UGA in plant identification, but most people are not familiar with a Formosan gum until they see this name, liquid ambar. So this species is an Asian cousin to our native sweet gum, liquid ambar formosana. It had a 30-inch trunk diameter. It was in very good overall condition. Its codominant form was a bonus given the site plan and the building plan. So earlier I said codominant forms were best preserved in groupings. Well, we were going to build a new grouping next to this tree. So the codominant form was actually a bonus. And then there was historic precedence. The forestry school planted this in the early 20th century as a possible crop for the timber industry. We're going to grow Formosan gum on tree plantations for wood products. This was their demonstration. And there was an existing parking lot adjacent to the tree. In that photo, you can see some shrubs. I think that was Nandina, heavenly bamboo behind it. There was a little scooter parking area and then a broader parking lot behind that. So we had some hardscape surrounding this tree that we could work with. So we created specific tree care plans, protected the actual root zone of the tree rather than just the plan view circle that said where roots existed. We protected the actual root zone and phased actions in coordination with the general contractors. They were able to work in phases, and the tree protection shifted as the project progressed. We created a pruning plan, and this is 3 dimensions displayed as 2, so forgive me that looks a little wonky, but with a minimal amount of pruning, we were able to clear what would be the full extent of the facade of the building. The tree care plan included accommodations for the new growing space. Adjustments in the facade construction allowed for maintaining the aesthetic. The general contractor was fantastic to work with. The ultimate building, which you'll see in a minute, had a brick facade. They wanted to have 6-foot scaffolding all the way around the building to construct the brick. But through communication and collaboration, we were able to reduce that to 3-foot wide scaffolding in the area where it passed the tree. And they were able to load those bricks a little bit differently in their sequencing in a way that allowed that to work so that we can minimize the amount of pruning that occurred on the tree. Communication made the difference. So here's some just phase pictures through the development process as the tree protection fence went up. It was originally in this photo on the right at the edge of the sidewalk. Sidewalk was demoed. There were no roots underneath it, but we still phase plans called for expanding that, but it was a good sign that we weren't going to encounter any roots. The photo on the left is actually where excavation occurred in the footprint of the old parking lot. This was for a lower basement and a shotcrete wall that was going to go in below grade for the building. We received updates from the general contractor through the process. This was on the left is actually before that, the previous slide, and the right as well. You can see the sidewalk still in place. Probably need to reverse these 2 slides in order. But here's our final product. That's the Poultry Science Building at UGA when it was completed. This photo was taken in, I believe, October of 23, but I don't know that I have that totally correct. But you can see in the right there is our Formosan gum, and that's a big brick building. If we had just removed that tree and come back with one of the 4-inch trees that you see elsewhere, the whole scale of that space would really change significantly and drastically. So this was a way that we could collaborate with the project team and create a good, positive end result. So cooperation, communication led to that. So wrapping up, we've talked about why and what and how. I hope this information's been helpful for you, but I'll leave with this quote. a good arborist needs to listen to the trees just as much as they need to listen to the people. Again, we are working in that interface. This is Kent Hull, one of my colleagues in ASCA. We're working at that interface. Kent's a great arborist. If you know him, I believe he's still practicing, but just working at that interface between people and trees create good solutions. So I want to thank you guys for your time today. Appreciate y'all.
We are
And we're
right.
at 12:59.
Yeah, we were right at the end of time. You did very well with the time there, Chris. Thank you. We did have a couple of questions about the Australian research that you mentioned. Is there any way that you could share that research or
Yes.
elaborate more on that? And if you want, you can just share a link and I can send it out with the recording that I'll send out.
Okay.
Or if you wanted to elaborate just a little bit on it, one of the questions was, can you elaborate that rough root cuts may actually be better for roots?
Yeah, so the initial research, they were looking at a few different species. I will find that and I will send it to you. I'm going to draw on memory here, so don't hold me totally to it. But what they found was it elicited a greater response. So you got more root initials that persisted longer from a rough break versus a clean cut on a root. If you're asking me my opinion on that, I mean, I think it just mimics a natural process more. We're seeing more out of particularly Australia, but you're seeing some in the EU with what's termed kind of environmental pruning, where we're, advocating for breaking branches rather than saw cut clean branches. We haven't used that yet in our practice, but the theory is you're retaining more of the natural systems. They're isolating a lot of trichoderma in many of these trees. So you're getting this beneficial boost of having kind of the natural systems operating versus our closer manipulation of those systems. So I think it follows some of that same guidelines, but it was definitely initial research. But if I do remember correctly, they worked with several different species and they worked with several different kinds of cuts. And I believe it was statistically consistent across the board that the trees responded better to breaks than they did to the clean cuts.
Yeah, and if you'll share that article with me, I'll make sure that every presentation receives that. One final question: Formosan gum, do they have gum balls?
They do, and that was a point. That was a point of consternation amongst the project team on this project. I think when some people just saw liquid ambar initially, it was a total, discard. Let's get rid of this tree. I think it took a little bit more time, but they do have gum balls. They're not quite as spiky as our native, but they're definitely still there.
Well, so just so everyone knows, the link for the survey to fill out for CEU credit is in the chat. So if you're looking for CEU credit, please make sure that you fill out that form. I'll leave it up for just a few more minutes. Thank you so much, Chris, for your time. I will include Chris's contact information in the follow-up email I send out as well. So if you have questions about being a consulting arborist or anything in the presentation today, please direct those to Chris. I can confirm going to the Consulting Academy is well worth your time. I went in 2019 or 2022, I think. And yeah, definitely worth exploring that if you're moving into the consulting world. So highly recommend. And thank you all for joining us today. I really appreciate it. Hope you'll join us for the next.
I'll give one more plug for the Academy. In 2026, it's in February and it's in Orlando. They generally do 2 years on the West Coast and 1 year on the East Coast. So it will be nearby in 2026. So there's really no excuse to go. There's 80 spots.
Yes. Yes. Yeah, I went to Palm Springs, so it was a journey.
Maybe better than Orlando, though.
Yeah, well, yes. Okay, well, thank you so much, everyone. And I hope to see you all in person soon. Thanks, Chris. Have a great afternoon.
Thank you. Thanks, Jesse. Thanks, everybody.
Bye.